Here's the thing about being human. Most of us spend our lives firmly grounded in the present. We plan our days, live our routines, and chase our dreams. But every now and again, something happens that reaches back into the past, pulling out emotions and memories we thought we'd left behind. It could be a song, a smell, a phrase, anything. But when it happens, we know we're not just hearing, smelling, or seeing. We're time traveling. And right now, somewhere between Earth and the edge of time, there's an experiment doing something similar. In the desolate plains of northern Chile, a behemoth named Alma is listening to the whispers of the dead universe. Its task is to detect radio waves left over from the dawn of creation, a relic of the Big Bang known as the cosmic microwave background. Launched in 2010 and operational since 2012, this giant telescope has been silently soaking up signals that carry information going back 13.6 billion years, the furthest we've ever seen. It's like having a window into the first minutes after the Big Bang, a moment we've never experienced, a universe we've never seen, and now we're getting ready to take the next step. This month, astronomers announced that Alma will soon listen to a strange and silent corner of the sky, one so empty of visible stars that it looks like pure darkness, a black hole in the fabric of space, officially designated EO507. This void lies in the constellation Volans and appears unremarkable under regular telescopes. But in 2010, a team led by Harvard's David Kipping noticed something weird. There wasn't supposed to be a black hole in the middle of the image, something big enough to warp the light of objects in the background. This discovery shook the foundations of astronomy. Black holes were no longer thought to lurk in crowded galactic centers. They could also exist in relative solitude, invisible but detectable through their gravitational effects on the light around them. Now, with the power of Alma, we're about to explore this lonely region in unprecedented detail. And what we hear may rewrite our understanding of the universe again. The reason for this has to do with what's called the Sachs-Wolf effect. Basically, as light escapes a collapsing star and becomes a black hole, it doesn't just vanish. It gets compressed, intensified, squeezed into a tight beam shooting in one direction. That tiny variation holds clues about the very nature of gravity and the internal structure of the black hole, but it's faint, incredibly difficult to detect, requiring the combined powers of telescopes like Alma and Hubble. The stakes are high. If confirmed, this breakthrough would unlock the ability to determine a black hole's properties from miles away. No longer would these mysterious giants be shrouded in mystery. Their masses, spins, and even chemical compositions would become readable like an open book. But here's where things get trippy. What we're about to hear might not just be a record of the past, but a message from the future. This is not just science, it's science fiction. The idea that we can hear signals originating from the future sounds insane. Yet it's rooted in Einstein's theory of general relativity, which tells us that gravity is not a force, but the curvature of space caused by mass. When we observe something very distant, we're not seeing it as it is, but as it was in the past, because light takes time to travel. The more distant an object, the further back in time we're seeing it. This means that if we study extremely far away places, we can observe events as they unfolded millions of years ago. But here's the mind bender. The same principle works in reverse. Signals emitted from the future towards us can reach back in time, arriving at our telescopes as echoes from the future. These aren't theoretical murmurs, they've been detected before. Fast radio bursts, or FRBs, are millisecond pulses of intense radiation, coming from across the universe. While their origins are still debated, many are believed to be from billions of light years away, sent out so long ago that they won't reach their destinations for millions of years. So, when Alma begins its vigil in the void, it's not just listening to the whispers of the dead universe, it's also tuning into the voices from the future. This brings us to a stunning realization. The universe we inhabit is not linear, it's layered. Every direction we look contains slices of the past and portals to the future. These are not distant anecdotes, they're part of our everyday experience. Every star we see is speaking to us across the past. Every fast radio burst is greeting us from the future. Our universe is filled with echoes, messages carried on the backs of photons. Across the vast expanse of space and time, this realization turns astronomy into something more than just the study of the cosmos. It transforms it into a conversation with the universe itself, a dialogue spanning billions of years, a conversation that transcends time. And now we're about to add another voice to this cosmic conversation, a voice from the depths of space and from the depths of the future. So, here's what to watch for if the Sachs-Wolf effect is confirmed not just from one black hole but multiple. We'll have a new tool to understand black holes not just as ominous presences, but as dynamic participants in the grand play of the universe. Second, as Alma listens to the whispers of the dying universe, it's also tuning into the voices from the future. These fast radio bursts are not just astronomical curiosities. They're greetings from millions of years ahead, carrying information about the universe we haven't seen yet. Third, if we're lucky, we might stumble upon something unexpected, something that doesn't fit our theories or challenge our assumptions. A message that forces us to rewrite the story of the universe once again. Remember, science is not just a body of knowledge, it's a journey, and every journey needs travelers. Will you join us on this one? Watch this next video to see what's happening in the largest void, in the observable universe, or click here to watch this video. Don't forget to subscribe to stay updated. Your curiosity keeps us exploring. Thank you for watching.